Okay, so welcome to part 2 of a very long question 1. I won't miss any of these out, so I felt I wanted to break up the video. There was about 7.5 minutes or so. Would get a bit too much. So here I am on the same page. That was H done before, and now I. Here we go. Well, what have I got here? I've got an isosceles triangle. If that's 25 degrees, then I think this is also 25 degrees as part of my working. I've got two 25s, which is 50 degrees, which makes this 130 degrees. Alright, just do the sums. 130 plus 50, 180, so that's correct. It's all about getting angle I. Now look, I've got a cyclic quadrilateral. If we just ignore this part of the isosceles triangle for now, I have an I've got a cyclic quadrilateral as shown, and we know the opposite angles add up to 180. Therefore, I is going to be 50 degrees. Okay? Opposite angles in a cyclic quadrilateral are supplementary. Let's just write the word supplementary there. Hope I've spelt it correctly. Now, after I comes J. What do we got here then? It seems that we have a quadrilateral. It's not cyclic because it's not touching. I don't have all four. Actually, it is cyclic quadrilateral, isn't it? Yeah, what am I talking about? Of course it is. I've got to work out angle J. Not a problem at all, because I know the opposite angles add up to 180, so I don't need to work out this one, but I do know that 120 plus J will come to, yes, 180. Therefore J is going to be 60 degrees. No more to be said about that whatsoever. That's it, 60 degrees. I was nearly fooled by the fact that it passed through the centre, making this line here a diameter, and I thought, is that cyclic? Well, yes, it is. All the four vertices are touching the circumference. The fact that they're trapped within one half of the circle is immaterial. So J's done. Nearly got trapped there. Now M. Very, very easy indeed. If we just draw a little chord down here, skillfully, sort of, I can see that I've got a triangle touching the circumference, forming angle N, and coming from the same chord in the same segment, I've got an angle 50 touching the circumference. Therefore N and 50 are the same, so N is 50 degrees. By the same token, if I use this as a chord now, I've got 10, an angle 10 degrees. It doesn't look like it, but just go by the maths, don't go by appearances. Here we go, 10 degrees coming off this common chord, and this angle A must also be 10 degrees. Or is it angle O? Sorry, it's O, because after N comes O. So here we go, that's 10 degrees as well. Alright, 10s, and a 50 into 50. Now what about this one? It looks a little bit crafty, doesn't it? Yep, they've given me, look at this, they've given me some parallel lines, so we're looking at alternate angles here. Now, what have I got? I've got a P there, and I've got a P there. Let's see what I can do with that. Now this is isosceles. Look, it says it quite clearly. So that's angle P and that's angle P. And incidentally, for that reason, I've proved that the angles in the same segment coming from a common chord are the same. Because look, P's there, alternate, and P. Wonderful. However, it doesn't help me get P though, does it? Well, here we go. Common chord, working in this direction. So I've got the angle P is exactly the same as angle 50, so P is 50 degrees. Now, I've already worked out lots and lots of P's here. I know that's 50 because of the rule, and I also know due to alternate angles that this P is also 50, and therefore I've now proved that this triangle here that I'm outlining is isosceles. There it goes. So I've got 50 and 50 is 100, therefore Q, I'll write it over here I think, so Q is going to be 180, take away the 100, let's just write it. Let's just take away the two 50s, just in case you misunderstand, and I'm left with Q is 80 degrees. Absolutely brilliant. And the last one, I presume, is the hardest one. We'll go for it anyway. I've got to work out angle S and R. Lovely. Well, look at it. I've got a cyclic quadrilateral. There it is. And you know the opposite angles in a cyclic quadrilateral are supplementary. That is, they add up to 180. So we can do a quick sum, can't we? We've got 1.5 S plus S equals 180. So we've got 2.5 S's comes to 180. So a single S is going to be 180 divided by 2.5. Quickly, calculator. I don't like decimals. 180 divided by 2.5. gives me 72 degrees. So S is 72 degrees. There you go, I've got you. What do we have here? Imagine a chord straight across there now. We have the angle at the circumference is half the size of the angle made at the center if you come off the common chord and you're in the same segment of the circle. So therefore R is going to be 2 lots of 72, and that's going to be 144, I think. Grab a calculator. Be brave. There we go, 144 degrees. And I think I'll stop there and I'll pick up some other questions in 11.1. Again, they require a lot of attention. I'm going quite quickly, and so I'll stop now and prepare a third vid quite shortly.